So let's talk about science. What is it, really? It's a huge question, and honestly, it can feel a little intimidating. But what if I told you it's actually something you do every single day? Today, we're going to pull back the curtain and break down one of the most powerful tools humanity has ever created.
When you hear that word, science, what pops into your head? Is it something kind of like this? Sterile labs, bubbling beakers, and super complicated formulas scrawled on a whiteboard? For a lot of us, science feels like this distant thing, something that's only for geniuses in white coats. But is that really the whole story?
To really get to the heart of what science is, we first have to bust a huge myth. It turns out it's not really about what science knows, but how it knows it.
Okay, so here's the biggest myth, that science is just a big book of facts. Like water boils at 100 degrees Celsius or the Earth revolves around the sun. And yeah, those facts are the products of science, but they aren't science itself. The reality is actually way cooler. Science isn't a what, it's a how. It's a way of thinking.
So, if science is a way of thinking, what does that actually look like in practice? Well, it's probably a lot simpler than you think. In fact, it boils down to three core actions that are just, well, incredibly human. It really comes down to these three things. First, you ask questions. You just get curious about the world. Second, you test your ideas. You don't just accept the first answer that pops into your head, you check it. And third, and this might just be the most important part, you have to be willing to change your mind when you see new evidence. That's it. That's the engine of science.
And here's the crucial point, the thing I really want you to hear. You don't need a PhD. You don't need a fancy lab. All you really need is curiosity and the guts to learn from what you see. If you've got those two things, guess what? You're already thinking like a scientist.
All right, let's make this super real. I'm going to show you how you probably used the scientific method this morning, and you didn't even realize it. Okay, picture this. You made a great cup of tea, but then you got distracted, and now it's cold. Ugh, you want to warm it up. This simple, everyday problem is the perfect setup for a little science. Now, before you do anything, you make a guess, right? Well, in science, we have a fancy word for that. We call it a hypothesis. It sounds really technical, but honestly, it's just a guess that you can actually test to see if you're right or wrong. So, back to our cold tea. You've got options. You could put it on the stove, or you could just leave it on the table. You'd probably guess that the stove is going to be faster, right? And just like that, you've made a testable hypothesis. See? Simple. So now you run the test. You pop the cup on the stove for a minute, and it's hot. The one on the table, still cold. Your observation proved your guess was right. You just did science to save your morning cup of tea.
Now, this little tea experiment, as simple as it is, perfectly highlights the single biggest rule in all of science. It's the one thing that separates it from just about every other way we try to understand the world.
And here it is, the one big rule. For an idea to count as scientific, it absolutely must be testable. That means someone else, anyone else, has to be able to come along, repeat what you did, and check your work. It's all about evidence that anyone can verify. This is what makes science so different from, say, magic. With magic, maybe only one person knows the secret to a trick, and it can't be reliably repeated or explained. But with science, anyone, anywhere in the world should be able to follow your recipe and see for themselves if they get the same result. It's kind of like a team sport, where the goal is to build knowledge that we can all trust and build upon. So, now that we get the mindset, let's make it even more practical. I'm going to give you a simple 4-step toolkit that you can use anytime, anywhere, for anything you get curious about. It really just breaks down into these 4 words. First, ask a clear question. Then, guess the answer. That's your hypothesis. Third, you test that guess. And finally, and this one is so important, you share what you learned. That last step is crucial because science only moves forward when we share our results with each other, whether we were right or wrong. And all of this brings me to what I think is the most important message of this whole explainer. It's a message about who gets to do science, who gets to be part of this amazing process of discovery. I want you to forget the idea that science is only for smart people. It's not. Science is for the curious. It's for every single one of us who is brave enough to look at the world and say, you know what? I don't know the answer to that, but I really want to find out. That, right there, is the true spirit of science. So please remember, science isn't some spectator sport. It's something you do. The tools are yours now. You have the framework. So I'll just leave you with one final question to think about.
What are you curious about? What question do you want to answer?